Here's a quick look at ionic bonding, which is a key concept in Year 11 chemistry. Ionic bonds are formed when a metal and a non-metal react, and we can show this using this diagram above, which is an electron transfer diagram. This one is relatively simple, and it's how salt is formed, sodium chloride. First, we start off with the atoms as they are. We have sodium with 1 electron in its outside shell and chlorine with 7 electrons in its outside shell. If you've learned anything about how atoms react, you know that they want to have a stable full outer shell of electrons. So to do this, the metal will lose the electron and the non-metal will gain the electron. So by drawing it out like this, which is called Lewis dot structures, you can see the sodium with its 1 electron in the outside shell, that's going to be transferred across to chlorine, which has 7 electrons in its outside shell. When it does this, sodium becomes positively charged because it lost a negative electron. Chlorine, on the other hand, becomes negatively charged because it gained the negative electron. And again, if you know anything about chemistry or science, you could have an appreciation that positive and negative will attract to each other. So you end up forming an electrostatic force or electrostatic bond. This is called an ionic bond between two ions, a cation, which is positively charged, and an anion, which is negatively charged. You can see down here that if this happens over and over again, you end up with a lattice of positively charged cations and negatively charged anions, and this is what we call an ionic bonding model. This ionic bonding model can be used to explain all the properties that ionic compounds exhibit, and they're listed below, just like we had when we had metals. First thing we need to understand is that ionic compounds are brittle, which means they'll shatter. And I can explain this by looking at this particular model here. If I was to shove this row of anions and cations up, what would happen is that this negative ion and that negative ion would be lined up and that would repel. So therefore you would have a shattering of this lattice. Secondly, we have electrical conductivity. As solids, ionic compounds will not conduct electricity because these cations and anions are locked in place. However, if we melt them or dissolve them, we will end up being able to conduct electricity because these charged particles can move. Lastly, ionic compounds have high melting points, which is due to the electrostatic force being really strong. The variation in melting points is between the different charges involved. So if I have, obviously, sodium chloride, this is between a positive and a negative. If I had magnesium chloride, it would be higher because magnesium's 2